Okay, lesson 5.4 is about inverses, contrapositives, and indirect reasoning. We have two objectives they are to write the negation of a statement and the inverse and the contrapositive of conditional statements. And objective 2 is to use indirect reasoning. So, I am actually going to start with the vocabulary again so that we really understand the key concepts here when we get going. First, the negation of a statement has the opposite truth value. So you can think of negation as opposite. Then there's the inverse of a conditional statement. Conditional statements are if-then statements. And you can only write an inverse for a conditional statement. So the inverse of a conditional statement negates both the hypothesis and conclusion. Then there's a contrapositive of a conditional, and that negates both the hypothesis and conclusion. But it takes it a step further. It negates both the hypothesis and the conclusion, and then it switches them. So instead of starting with the hypothesis, you start with the conclusion. Okay, then a conditional and its contrapositive always have the same truth value. It will be important to remember. Then equivalent statements also have the same truth value, so they can't be equal if they aren't both true or both false. And then indirect reasoning. In indirect reasoning, all possibilities are considered. After you consider all the possibilities, then you prove all of them false except one. So all possibilities are considered, then all but one are proved false. So you consider a whole bunch of things and you just keep crossing off one at a time until you get just one possibility. And then an indirect proof is a proof involving indirect reasoning. So nothing too crazy there. Okay, so let's back up and check out some of these key concepts here. The first is a conditional statement. The example is if an angle is a straight angle, then its measure is 180 degrees. So it's an if something happens, then another thing. We write this P arrow Q, and the way you read that symbol is to say if P, then Q. Okay, the negation of a statement. So example, an angle is not a straight angle. Negation, we used the word not. This little squiggly means not, so the squiggly line then P, we would read that as not P. Okay, so then the inverse negates both, right? We talked about that in our vocabulary. The inverse negates both the hypothesis and the conclusion. P is the hypothesis, Q is the conclusion. So the way we would read the symbolic form for this would be if not P, then not Q. And then last, the contrapositive. Remember, the contrapositive negates both the hypothesis and conclusion and switches the hypothesis with the conclusion. So like usually it's P then Q. Here we've got Q then P. And the way we would read this is if not Q, then not P. Okay, and then the last main thing we need to talk about is writing an indirect proof. So there are 3 steps. The first step is to state the assumption, state as an assumption the opposite. Remember, we said the opposite is called the negation of what you want to prove. So in a direct proof, we said, okay, this is what we want to prove. We're going to start with that. In an indirect proof, we're going to say, okay, we're going to assume the opposite is true and try to prove that false. So the second step is to show that the assumption leads to a contradiction. And step 3 is to conclude that the assumption must be false and that what you are trying to prove is true. So since the opposite was false, that means that what you want to prove is true. Okay, so now that we have all this new information, let's go put it to work in some examples. Example 1, write the negation of the statement. ABCD is not a convex polygon. So the negation of the statement has the opposite truth value. The negation of a statement is, like if we're using is not, like we are here, the negation of that statement removes the word not. So if we write the negation of this statement, it would be ABCD is a convex polygon. Because they were using is not, so we used is. Okay. Example 2. Write the inverse of in contrapositive. So the statement says if triangle ABC is equilateral, then it is isosceles. First, we are going to write the inverse of the statement. Okay, now remember, inverse means we negate both the hypothesis and conclusion. So if ABC is not equilateral, then it is not isosceles. Okay, that's the inverse. Then we're going to write the contrapositive. Okay, so the contrapositive negates both and switches them around. So, if ABC is not isosceles, then it is not equilateral. And that's the contrapositive. Alright, then let's look at the steps for an indirect proof. We're just going to write the first step for this proof. So we're trying to prove a triangle cannot contain 2 right angles. The first step is to assume that the opposite is true. So we're going to assume as true the opposite of what you want to prove. Because you want to prove that a triangle cannot contain 2 right angles, you assume that the triangle can. Okay. So the first step is to assume a triangle can contain two right angles. We're only working on the first step, so that's it. That's all we had to do. Okay. All right, there's a few more examples in this lesson than usual, so stay with me here. Identifying contradictions. Remember, two statements contradict each other when they cannot be true at the same time. So we're going to look at each statement. So 1 says PQ and R are coplanar, 2 says PQ and R are collinear, and 3 says the measure of angle PQR is 60. So coplanar and collinear. 3 points that lie on the same plane are both coplanar and collinear. So they can do that, so these statements do not contradict each other because a line can be in a plane. PQ and R are coplanar and their angle is 60 degrees. 3 points that lie on an angle are coplanar, so these statements do not contradict each other. Now, this is saying collinear and that they form an angle of 60 degrees. If 3 distinct points are collinear, they form a straight angle, so the angle cannot be 60 degrees. So these two statements do contradict each other. All right, the last example is writing an indirect proof. We're proving ABC cannot contain two obtuse angles. So we're going to assume true the opposite of what we want to prove. So we're going to assume that ABC contains two obtuse angles. We're going to let angle A and angle B be obtuse. If A and B are obtuse, then the measure of angle A plus B plus C is greater than 180 degrees, which contradicts the triangle angle sum theorem that says angle A plus B plus C has to be equal to 180 degrees. So the assumption in step 1 must be false. Triangle ABC cannot contain two obtuse angles. Okay, what I need you to do next is do the check for understanding problems. There are 5 of them, and I will make a video going over how to do each. So go ahead right now and pause, do those problems, and then once you've tried them, watch the next video on how to do them so you can check.